Great. Great to be here. Nice to meet you all. And I'm going to also be talking about threats in CI/CD pipelines, but fortunately, from a different angle than the previous presentation. So I was very relieved that we didn't overlap. So you're going to see something else and not the repeat of the same thing. So without further ado, about me, I work at Ignite now for 9 years. I spent my first 7 years as in a DevOps team, as a DevOps engineer, working mostly with GCP Cloud, Kubernetes, and database, all the stuff around the product from DevOps perspective. And then I decided to switch to cloud security team. As a DevOps guy, basically I knew well where all the bodies were hidden, so I decided to take up a shovel and dig out everything, all the dirty secrets that we kept hidden over the years, and start working on the security of the platform. So, what's this topic about? Why did I say DevOps gone rogue? Well, the whole topic is around a hackathon that we did at the company that took 2 days, and basically they said to us, well, do any scenario you want, do any attack you want, or whatever testing, go wild, you have 2 days, try different things. So, in the presentation we're gonna go over scenario, attack vector, exploitation, the expansion, and basically lessons learned from this whole experience. So, for the scenario, I decided to choose insider threat and try to pose as a regular developer in the company with access to stuff like Git, Jira, Jenkins, wikis, Slack, SSH access, regular stuff that developers have. Why? Well, as you know, most of the companies hire people now remotely, and as you may have seen, there have been some interesting cases where AI has been used to impersonate somebody else. Some people fake recruitment calls. So there is actually a possibility of somebody impersonating a developer just to gain access to the company. So that's actually a real scenario. Not to mention that a compromised account could work just as well. So the goals were to gain unauthorized access to private services, the stuff that developer shouldn't have access to, avoid detection by all the security tools available for the security team, and achieve some long-term foothold. So it wasn't about just doing one attack, one quick, just gain a permanent foothold and stay hidden for a while. Okay, so let's talk about attack vector. For the entry, I decided to use 2 approaches. One was to leverage GitLab CI, and the second was Jenkins. Goal was to try to execute some arbitrary commands on CI without anyone noticing. So nobody else from developers, etc., and hijack some permissions to build or deploy something in production so that I can deploy something malicious and gain some more access or exfiltrate data. So first one was GitLab. And here my first question, how many of you have in your company or your organization some tools repository? A repository where you have some BusyBox, some tools, some stuff like that. Yeah. So some of you have some miscellaneous tools repo. And we also had this kind of repository. As you can see, this is the CI file for it. We had some BusyBox, some gcloud, some CI tools, some debugging tools there. Basically nothing that really was of any particular product, just general tools used by different teams. And in it, you can see that there was this script that was building and pushing the images. A simple build and push shell script. Inside it, it looks something like that, right? So first, it authenticated to Docker registry and started building images. If it was built from master branch, then it pushed stuff to the repository. So how to attack this kind of pipeline if you have a developer access from it? Well, very simple. Just make a branch and change the CI script. Basically, if you have a repository where from every branch, merge request, is being built to check, for example, if images are correct to have a pipeline, and the scripts are present in the same repository, then you can modify the script. So in this case, I decided to change the script, do an echo. I added this base64 because many CI tools have this, that they detect secrets if you print them out and then they obfuscate it. So I pushed it through base64 and voila. I had a base64 encoded service account key that I could use then to push any image I want to the container registry, override anything I wanted. So the process here was very simple. Find the repository registry access, create new branch, modify CI file or build script, and extract secrets, credentials, whatever is there. So with that, I gained full access to our Docker image registry, not just for the tools, for the entire production, because it turned out it was the same repository for most of the applications, and the tools repository also had access there. And the problem here with vulnerability was that there was no isolation for the CI configuration. So the script was in the same place where these other repositories with the Docker files. No isolation for permission, and static credentials. And those credentials were actually really static credentials. I could take them out and use them for next year. So there's that. But let's not stop there. Let's go to Jenkins. So for Jenkins, basically we had this setup where in the Jenkins instance, there's going to be application building jobs and deployment jobs. And the developer has access to application repository, obviously, because we're adding new features, stuff like that, having branches. And there was also ops repository, and there was this deployment job for the ends, but developers did not have access to trigger it or make changes in that. They could view it, obviously, the deployment status, but not necessarily change it. And application build jobs used special VMs with access where they build the application images, and the ops jobs use different VMs that have permissions to change stuff in production repository, in cloud environment. And this time, there was no typical kind of static credentials because we used identity of the VMs. You could create in GCP a VM that has a service account attached, and you could use it to have some permissions. So in this scenario, the application repositories use something called multi-branch job. How that works? Well, again, every branch you create, it will have its own build. You can check the status. You can check if test pass. So as you can imagine, similar case as the previous one. Well, we can target the Jenkinsfile, the pipeline job script. So this is how the application job looks like. And this was the deployment job pipeline. So first one obviously builds, does tests, and the other one runs a deployment. The important part here is this one, the specification of agent or the node, because this is the part that specifies which VM should be used to run this, could run the CI pipeline. And this, as I said previously, the VM that it runs on was directly attached to service account that has access. So what we did? Well, basically, you just have to copy the code from the deployment job to your own branch to the Jenkins file. Obviously, remove some of the parts like notification about failures or logs because you don't want, again, nobody to notice that you're messing something up. And change the node and do a gcloud ping access token because you want to have this access token to use for something else. And this way, even though I didn't gain access to the actual deployment jobs, I could create this job with an actual production VM agent and make changes to production environment. So here, scenario was, again, find multi-branch job, create new branch, modify pipeline script, run pipeline or high privileged node, and with that, you could extract credential secrets, stuff like that. So permission to execute production deployment was just like that. And the reason here, the problem was that no permission management was between the jobs and VM agent, and probably the application jobs shouldn't be allowed to use these VMs. But fun fact, Jenkins doesn't have that feature. You cannot really restrict that between the jobs. So that was the entry, that was the attack vector. So what about the exploitation? What about actually using that? So here let's focus on the GitLab scenario because it's much more fun. The Jenkins was too easy. If you can deploy it, it's like cheating. So let's take the hard way with it. So in this scenario, we had like this GitLab CI job that pushed Docker images to the registry. In the registry, we also had Helm charts. And the Helm charts were, who knows what are Helm charts? Yep, okay. So Helm charts are basically manifests for Kubernetes saying how to deploy the application. So it specifies how it runs, what it exposes, what parameters does it use, basically everything about how it's going to be run on Kubernetes. We had Jenkins to run it, and obviously containers of Kubernetes. So basically the scenario here, the most obvious part was that with the credentials that I stole from GitLab, I can now replace the image in the registry, just push a new image, and it's going to get pulled into the Kubernetes cluster and run in production. But there are some hurdles here. First of all, there is now Wiz sensor and Wiz Cloud connector in the environment. Who knows Wiz? Yeah. So for those that don't, Wiz is a security tooling, a CSPM, and a monitoring tooling. And in this scenario, for our case, basically we had two parts of it. First of all, the cloud part monitored deployment of every image and its content. So if I pushed a new image and put, let's say, Nmap inside or some tool to do some exploitation, it's going to get detected immediately because it scans every image that is being deployed. Second of all, even worse, we had this Wiz sensor that is running on every node, and it detects every action that you do, every open connection, every DNS query, every open file, and stuff like that. Everything gets monitored and checked. So, well, that restricts our ability to do malicious stuff a lot, because we have to avoid known exploits malware, avoid suspicious command executions, avoid suspicious tooling, and avoid external connection that would get flagged if I wanted to push data to my own, let's say, server somewhere outside. So that causes a bit of a problem. So how to work around that? First of all, let's do something that's called living of the land, basically, which is use what's already there. Don't push some image that you have built from Docker Hub. See what's in the registry. Use, for example, an existing Python image that already has all the labels. It looks like an image that the company is already using, same name convention, because it already will look like an application from the company product portfolio. So that was part one. Second part is I decided to use other cloud services like Google Cloud Storage and Google Cloud PubSub. Why? Because we use them in the company as well. These are cloud services that we already use in the stack that are familiar, and what's even more important, for those services, no matter which project you use, which organization, they have the same IPs. So from the sensor perspective, if you're connecting to a storage bucket in your organization or your own malicious bucket, it looks the same. Because you're making requests to storage googleapis.com, it has the same API. All the content stuff is in the request content, not necessarily in the connection. So with that, it's indistinguishable from any normal traffic from the application. So I did something like this serverless command and control. Basically, it was kind of automation that to help me see how well my malicious application is spreading. First part was that every application that was with my malicious code was posting its status to my GCS bucket. So it posted a health check, so I knew which one was actually running with its name, and also with other data like environment variables, GCP access token, Kubernetes token. It tried to pull all the data it could and pushed it to the bucket. The second part of it is knowing the ID of my container. I could create in my own project two PubSub topic and subscriptions. PubSub is like a queue system, basically where we push messages and they later. So basically I created this duplex where I had command channel and data channel. So I had a server side running on the application, and I had my own CLI tool where I just write a command attached to this. I write in a command, it gets sent over a PubSub, and on the server side, it just executes as a shell command, and I get the output back on the PubSub channel. So basically, I had this interactive remote shell with a little bit of latency, but basically working like a charm. So with it, the idea was use custom tool, written by myself, not something that is easily detectable as a malware. This is very easy now with AI, because you can ask it, oh, just write me a malware. So the signatures is going to be different from whatever is available, because every single one is going to be a little bit custom made. Use known cloud services and API to stay hidden. Every app was already uploading its data. So I already got the access tokens from production immediately to my GCS, so I could already use that to get some stuff. And also, many containers can have secrets in environment variables, so already access to secret, nice. And this pops up if I want to do anything else. Additionally, I also configured this PubSub GCS with configuration to allow access to all users. So basically, I configured to be to allow write for any unauthenticated Google account. So basically, any one of you could probably write there. Why? Because I didn't want to store any credentials, any key within the container image, because then this Wiz cloud scanner could detect that my container image, my malicious one, has some static credentials, which would be a security issue and would get reported. So this way, I managed to bypass that and basically upload anything. Result, ability to override and poison application images, access point in production with ability to execute anything, ability to steal credentials and attempt data exfiltration, which is almost undetectable. But I said, okay, let's move a bit further. Let's try to go even more. Because main problem for me was that we still had this pesky Wiz sensor. So basically, if I tried to run multiple curl commands, try to exfiltrate data, there is high chance I'm going to be noticed. There's high chance I do something that's going to trip me and the whole ruse is up. And then I noticed that in the same registry, there are Helm charts. What it means, because this used the OCI registry patterns, and it was the same registry as Docker, that means I could override the Helm chart. I could change how applications are run, what parameters are being added, what permissions they had. So I could actually attempt easy privilege escalation. But I noticed something else. In the same registry, there was a Helm chart for Wiz sensor. And yeah, basically that was game over for the whole thing, because with it, I could replace the image of Wiz sensor, and with one quick step, I disabled the entire monitoring on the cluster and gained access to an application that was on every node, had already highest privileges available in the system, and could do almost anything unnoticed. So as I said, result was threat detection was disabled, high privilege foothold on every node in the cluster, prevent detection because I used existing deployment. I didn't deploy any new component. It wasn't an additional sidecar. It wasn't an additional app. It was a Wiz sensor which was known, and it gave me even more ability to abuse because, as you may know, in many environments, all security tools are usually exempted from all the monitoring, all that kind of stuff, because they obviously have high permissions. They obviously make requests to everything. So everyone by default just does an exclusion from alerting, okay, this one is running whatever. So basically that gave me full control over everything. So at this point, what we learned and basically where to go from there? The attack path can be best described as a kind of these 3 steps. First was this poisoned pipeline execution, where basically we decided to change a behavior of CI/CD pipeline. Then supply chain attack via first Docker, then Helm chart, and finally compromised security tooling to give us kind of like full visibility, full access. So let's take a look at each of those parts. How to secure CI from internal threat. Well, the problem is, if you work in any company that adopts DevOps principles, is that CI/CD tools are now designed to be for ease of use for developers. And it's not a bug, it's a feature. We want that. We want developers to manage CI/CD pipelines themselves, to take active role. So also, isolating everything may seem a straightforward solution, but is expensive because it adds maintenance. If you, for example, create a different Jenkins instance, different GitLab instance for every repository, for every use case, it's going to get really expensive and difficult to manage very quickly. So a DevSecOps solution would be something called Workload Identity Federation, and using the OpenID Connect tokens. Which was something I mentioned in when we had these previous questions. Basically, with that, instead of having static credentials or even tokens for specific VMs, we can actually assign permissions to branches and not rely just on script logic, on the logic if branch equals master, then do something. No, give permission only to master branch. So with it, that's basically the schematics of it. I won't go too much into the details because it's actually a topic for another hour to talk about it. But generally, most of modern tools like Jenkins, well, Jenkins is not really modern, right? But still, even Jenkins allows it configuration, but GitLab, GitHub Actions, and all cloud providers, Kubernetes, allow this configuration where you can federate different identities. So you can use identity from GitLab to get access, for example, to Google Cloud. So you can give access, for example, to this repository for, let's say, this repository, this Docker tools branch master has write permissions to this Docker registry. All other branches can read from it, can build images on their own, but they cannot push it. And that immediately saves a lot of problem and also kind of saves many of the issues with stolen access tokens, right? But how to prevent next the internal supply chain attack? Well, there are a few methods. First of all, you can use SHA-digest for the images, because if you use the digest instead of just a tag, it will ensure some integrity. But obviously, it's kind of annoying to use, to be honest, for most parts. So some recommendation would be to use immutable tags on registry. What that means is that if you push an image with a tag, the image cannot be overwritten. So basically, if I push application with version 101, I cannot change that. It stays baked in, and that guarantees that if some attacker gets access, they can push new images, but not necessarily override the existing one. Second, sign images. and verify them with admission controller. So on the build cycle, if you build images from your CI, it should be signed, and then on Kubernetes or whatever ecosystem you're running on, you can verify those signatures and ensure that these were built from your Jenkins pipeline or GitLab or Git, whatever, and not built by some malicious attacker on their own laptop, because they're not going to get deployed this way. And thirdly, separate registries. So not necessarily for everything, but you can, based on projects and on criticality, to use different registries so that not everyone has right access to the same registries, and you can separate a bit based on that. And third part, how to secure monitoring tools. So first of all, the deployments of monitoring tools should be held to a higher standard. So even if you, let's say, cannot deploy this SHA digests and integrity checks for all the application in your system, do it for the critical apps, for monitoring tools, for cluster critical daemon sets that have high access monitoring tools. Held them to a higher standards, and if something gets compromised, at least it's not the critical components. Second, monitor coverage of your security monitoring. So don't just rely on things that's being deployed. Check actual health check, monitor if the tool that is there is actually there, if nobody disabled your security monitoring, your security tooling on the production system. And third, also as I mentioned before, additional integrity check for high privilege components, right? And that's it from my side on this attack path. Any questions?
A quick question about the command and control layer of the exploit itself. So how do you think, if application that was executed inside the container would be restricted by principle of least privilege to certain pub subtopics or to certain, I want to say it bucket, but it's not bucket, it's object storage instance, would it make the specific exploit path that you demonstrated impossible?
Not really. Because the way you would restrict access is you would give only permissions to the right topics, right? And the thing is, I configured my topics in different organizations with allow all users. So basically, any identity could push that.
Yeah, so you control the permissions.
Yeah. If you restrict, if you restrict it, for example, firewall or network stuff, this is still using the API, the same thing.
Right.
I think maybe you could use service perimeter, something like that in GCP, that would restrict it to your organization, your project, but that is double-edged sword, because if in any place you use, for example, bucket with public artifacts, they would stop working as well. So basically, I know that most people don't implement that because that is just a
more complicated setup. Gotcha. Thank you very much.
We lost the cube. Hey, Michał, thank you very much for your, let's say, show and talk. Just a question, I didn't get exactly how did you operate with PubSub and sending commands? I mean, the most, what I don't understand, how you impersonate it. You mentioned that it is, it has the same IP as storage. That's why your cluster treat that service as storage, which is allowed?
No, not necessarily. This is a service which you would call over pubsub.googleapis.com. It is a different IP than the storage.
Okay.
But how I used it. Basically, you would refer to the PubSub topic with topic ID, which is project / your project name / the topic name, right? And the way I figured it out is that I used the convention where, okay, I had project, my project name, which was outside of organization. And then, for example, CMD dash, And then I used a UID generated randomly when the container starts. Okay? And at this point, there is the topics and subscription, they don't exist yet.
Okay.
The container starts, it pushes the health check status to GCS, to the bucket. It registers, hi, I'm here, I'm malicious, this is my ID. So now I can create this topic, and the script in the container is just checking every minute or something like that if a topic with this name exists and tries to listen on it. So the moment I create this topic with this name, it starts listening on it and starts receiving commands that I send.
Okay, programmatically, yes, but from network perspective, was your cluster and PubSub and storage in the same network segment? Even
PubSub is globally available service, and GCS like Google Cloud Storage as well. So from the Google PubSub perspective, you can use it from this network, from whatever network. You just have to have credentials, and it doesn't really matter. There is no network isolation as such. It's
but I hope your cluster or the one you tried to attack was a private one, or
doesn't matter, because in our company, we already were using PubSub for different things. So we already, even if you use private network, you would configure something called Google private Google API access, and it would route the request via private call, but that doesn't restrict you only to your organization.
Okay, but even if you don't need to use within your project the PubSub, PubSub will be able to access your Kubernetes cluster, even if you don't need that. Any kind of other project team which using PubSub could configure their PubSub to access your Kubernetes cluster, right?
It's on its pool side. It's not PubSub is going to have access. The application is making call to PubSub API.
Okay. Okay. In this case, it, at least for me, doesn't matter. I mean, there is allowed by default this connection from this cluster.
Yes, because I use the services that other applications in the cluster were already using.
Okay, I get it.
From the product perspective, right?
Get it, yeah.
I didn't use any new service. I tried to use the service that were already used by our application, because I tried to mimic whatever is already running there.
Okay, I think I get it. Thank you.
Questions, more?
We can see problem. We can see a solution, but from your experience, up to you, who is responsible in company to implement this DevOps, DevSecOps? Of course, it depends how big is company.
But question is clear.
It depends, I guess. I would say cloud security is responsible for setting up standards and possibly also setting up checks later on. For example, in CI/CD, you can specify, I would say, for example, security with the DevOps collaboration can work on securing registries, adding image signing, admission controller, stuff like that, monitoring. So I would say it's between security and the DevOps team. But generally, I would say important path is to increase the awareness, because in the end, everybody cares a little bit, so it's a good thing to be aware how it can be used and abused. So I would say that's kind of the primary goal.
Thank you for your talk. You said several times replace image, but we can set pull policy to pull image once, and additionally, you can make your artifacts, images immutable.
Yes.
So what did you think about this?
So immutable artifacts, yes, that was also in the lesson learned, that we can make these immutable tags, and that would work, or use shard digest. we didn't have that, so that was how I managed to use it. Regarding this image pool policy, it didn't matter because basically our clusters were auto-scaling like crazy because we had like over 1,000 nodes, then 500, etc. So nodes were recreated all the time. So every time new node is being created, it doesn't matter what's the policy because it's gonna just download the image again. So.
Oh, yeah, it's just to make harder to replace image.
I guess, yeah. I mean, we did have this policy, but in the end, I managed to overtake it as well. So it didn't hinder me at all.
Okay, thank you.
Yeah, thank you for your talk. It was really good. I have a question regarding that federations you talked about. You showed that you integrated with Google Account Management using OpenID, but is it some built-in tool in GitLab or Jenkins that could be configured? Because, well, to communicate with Google, you need to establish communication with some security between your CI tool and Google via REST. And, well, for example, can someone hack it, trick it, well, to get token? Because, well, yeah.
The way it works is that if you configure this OpenID provider on, let's say, any of the tool, like let's say GitLab or GitHub Actions, for example, they're going to issue the token, and then you have Google Credentials configuration that is basically saying how to exchange the stuff. So let's say you use then the GCP library or whatever, or gcloud command, it's going to have this configuration and works automatically. You have to have Workload Identity Federation pool configuration on GCP side that basically says which issuer you trust and how you map this identity. And how is it vulnerable? It is vulnerable if you compromise the OpenID provider. So basically, if you hack GitLab, then yeah, it's vulnerable. Same idea with GitHub Actions. Basically, if the token that GitHub Action uses is leaked, then it's going to get compromised, or if GitHub itself gets compromised. Otherwise, it's difficult to basically attack it. And the same thing can be used also for Kubernetes if you run in different ecosystems, and also cross-cloud connections. So for example, we also have Azure ecosystem that needs to access some GCP resources. So we also use this identity federation, and we don't need to store any static credentials. It uses this federation to exchange the tokens.
So basically, it's still configured by repository owner and stored like somewhere internally. So it's
issued. It's short-lived, the token.
Oh, yeah.
So basically, you have a token that lives usually around an hour. So, and this is a live token every time, and you just have to exchange it, and the library is just supported out of the box. So you don't have to add any other additional code. You just add a proper configuration of the identity, which is sometimes a bit difficult to understand, because that's why I didn't talk a bit more, because I would have to talk an hour about it. But if you use already existing wrappers, it can be a very, very safe way to use it, because even if something is leaked, it's temporary, right? The important thing is don't give an attacker permanent access.
All right, thank you so much for explanation.
Hi, hello. So thank you again for the presentation. So talking about all presentation, I want to ask, like, does this can be mitigated by just implementing supply chain SLSA on level 2, or like, okay, level 3, it's mostly impossible, like on level 2 framework. So, I mean, when we sign the containers, when we provide the provenance files and do not deploy anything not signed to the containers, I think it's could be enough for the starting to mitigate all these issues, even with GitHub Actions, GitLab CI, or Jenkins itself, when we attack in the production cluster.
Yes and no. Why? Basically, any kind of signing and ambition control is a great defense against supply chain attack, right? Which is great. But as you saw in these cases, it depends which element of the pipeline you attack, right? Because obviously you have pipelines that are responsible for building image and pushing it into registry, but you also have pipelines responsible for the deployment itself, right? So what if you hijack a deployment token and basically you have some control over deployments in the cluster and basically remove admission controller? Maybe you can do that. It also depends on least privilege, how you have handled this kind of stuff. And with SLSA and SBOMs, I mean, it depends what you're actually checking. Are you checking the image itself, or are you also checking, only dependencies? Because, as I said, if you write your own script, then you can bypass dependency checks or checks based on checksum, stuff like that. But I would say, yeah, signing images and having an admission controller that verifies that is a great first step. But sometimes you can also compromise the pipeline and basically make it build a compromised image for you. So it's not, sometimes it's not enough.
Okay, thank you.
Yeah, basically in the security front, nothing is ever enough. Basically, you have to protect yourself from all the angles, if possible. It is possible, but it's expensive.
Yeah, thank you so much. Thank you, Michał.
Thank you.